One of the best and most enduring ideas to come out of the early development of programming languages was the idea of a function. A function really is a very simple idea. It says, suppose you have a bunch of code that you want to run over and over again with minor variations. A function lets you package up that code, so it takes a few variables as inputs, it does the same thing every time, but it uses those variables, and then maybe it returns a value to you. We've already seen lots of functions. For example, rect is a function. This is a function that is part of processing. It takes 4 inputs and it draws a rectangle. And in this case, it doesn't return anything, but the operation of the function is to draw a rectangle. Functions are so useful that you will soon be creating tons and tons of them for yourself because they're a great way to package things up and to break down a big problem into small pieces. In this video, I will show you how to declare and write a function. But to get started, let me just show you a program that uses a homegrown function, and you'll see why they're so useful. Suppose I want to draw this picture. There are 9 ellipses here. But clearly there are 3 groups of 3 ellipses, and they're all pretty much the same. There's a big, bright ellipse, a smaller, darker one inside of it, and a smaller, darker one inside of that. So I could create this picture by drawing all 9 ellipses and typing in 9 calls, and that would be just fine. But there's another way to go. I can write a function that says, draw a stack of 3 ellipses. That function takes as input the location and size and color of the biggest ellipse, and then it automatically draws a smaller, darker ellipse inside of that, and a smaller, even darker ellipse inside of that. The value of writing that function is now, I call it 3 times with 3 different large colored ellipses, and it takes care of drawing all the inner ellipses for me. If I want to draw 5 more stacks like this, I don't have to type in 15 more ellipse calls. I just call the function 5 more times. Let me show you what this looks like. Here's the program with the exception of the function itself, which we'll get to in a moment. The first few lines are nothing exceptional. I define a setup, I call size, I call smooth, I call no stroke, all stuff we've seen before. Draw itself is really not that special. The first line is I draw the background. The next 3 lines, I define some very bright saturated colors, yellow, cyan, and magenta. So far, all stuff we've seen before. And here's the interesting line. Drawstack with 4 numbers and a color. Drawstack is the name of the function that I wrote. That's my own little function that says, take an ellipse, and these 4 numbers are the x, y, width, and height of the ellipse, and a color, and it draws the stack of 3 ellipses. Then I draw a stack using the cyan color, and I draw a stack using the magenta color. Drawstack is, of course, in this program. I just put a bunch of vertical space in there so it would scroll off the bottom of the screen so we wouldn't be distracted by it until now. I'll get rid of the vertical space, and just so it all fits, I'm going to scroll the setup stuff off the top of the screen. So here's Drawstack in its entirety. This is everything there is. And in this video, we will talk about all the pieces, but I'll give you a real quick walkthrough. Void says this thing doesn't return a value. We'll talk about return values, but its name is Drawstack. So this is how it knows when I say Drawstack with a bunch of values, it knows which routine to call. It looks for one with that name. Then I have a pair of parentheses. And these tell processing, here comes a list of variables. These are the inputs to Drawstack. The first input is a floating point variable named cx. So it's just a normal variable declaration followed by a comma. Then the next variable, it's also a float, and I'm calling it cy. So those are the center x and y of the ellipse. Then I have a float for the width of the ellipse, a float for the height of the ellipse, and a color, which I'm calling CLR. So those are the inputs, and the function starts with this curly brace and ends with this curly brace. In between, it's just a bunch of normal lines that we've seen many times before. The first thing I do is I pull apart the color variable into its red, green, and blue components, and I store those in floats. Then I call fill with that color, and I draw an ellipse. Then I call fill with the red, green, and blue values multiplied by 0.8. That makes them all a little bit darker. And I call ellipse, where the width and height are now also multiplied by 0.8, which makes it a little bit smaller than the biggest ellipse. Then I fill with the color values multiplied by 0.6, that makes them darker still, and an ellipse multiplied by 0.6, and so it's darker still. When I run this, we get 3 stacks of ellipses, where each stack is coming out of Drawstack. As I mentioned a moment ago, the general idea behind any function is some variables go in, the function does something, and then perhaps one value comes out. Once you start thinking of functions in this sense, things that take in variables, do something, and maybe return a value, you see functions everywhere. For example, suppose that you have an in-dash nav system in your car. Well, there's probably a little routine in there that takes in the car position, heading, and zoom factor as inputs, and it draws the map. And in this case, it doesn't have any output. As those inputs change, the position of the car changes, you turn, the heading changes, you zoom in and out, it just calls the function again, and it draws a new map based on the new variables. Let's take a look at a function that returns something. Suppose you have a feature phone, a little cell phone that is filled up with minutes that you buy from a card, say at the grocery store. So you scratch off the number on the card, you type it into the phone, and it says, "Congratulations, you have another 100 minutes to call with." The phone or the company responsible for it might have a little function. The input is the card serial number, the current minutes on your phone, and the number of minutes that you've just purchased on the card. The function, which I'm calling validate, makes sure that the serial number is okay. It does everything it needs to do internally to add those numbers to your account. And then the output is the number of new minutes, which the phone will probably display to you. Congratulations, you now have 250 minutes. So the function takes in a bunch of information, does something, and gives you a result. As I've said, if you think about this and you look around the world, you'll see unlimited numbers of examples. For example, suppose that your gas tank is empty. So you go to the gas station, you fill it up with gas, and now your gas tank is full. What's happening? Well, we can think of this like a function. The input is the amount of gas in your tank right now, and then the amount of gas that you've put in. The function is what the little meter is doing when it measures how much gas you have. The output is the new position of the needle, where it says, hey, now you're full of gas. So functions are things that take in inputs, they do something, and then maybe they give you back a value. I've been describing these things with the words inputs, function, and value. These ideas are so common in the world of programming that almost naturally they've come up with a bunch of synonyms or near synonyms for each of these ideas. Instead of inputs, sometimes they're called parameters or arguments. And in this case, argument doesn't mean a conflict or a disagreement. It's just a word that comes to us from mathematics. So a variable that goes into a function can be called an input or a parameter or an argument. And that's just the language. Functions themselves go by lots of different names. They're called procedures, subroutines, methods, and sometimes just simply a routine. In fact, these words often have slightly different meanings technically, but for our purposes, they're synonyms, and you'll hear me refer to functions as routines or procedures pretty much interchangeably. Finally, the value is sometimes called the output or the return value because it's returned by the function, and in fact, we'll see that we actually have a return statement, a keyword return. So all of these words on the right are synonyms for the 3 ideas that I've been describing on the left using the words inputs, function, and value. And you'll hear me use all of those words on the right because they're just part of the language and everyone uses them more or less interchangeably. So it's good to get used to them. So now that we know what a function is, we are ready to start writing our own. We'll dig into that in part 2 of this video.